Hello, welcome to Ed School, everyone. This is the mechanical property of fluid, part 1. In this video, we are going to understand about a little introduction about the fluids. So, what is a fluid, first of all? It is a substance that can flow. The substance that can flow. Now, what are the two substances which you see around you which are actually flowing? For example, in the rivers, water is flowing, while surrounding to you, the gases are flowing. That's why you are able to breathe, right? So, the fluids, those are surrounding to you, and which you see flowing can be the liquid as it can, and it can be gases. So, the two fluids are liquid and it can be gases. Liquid is not particularly only water, it could be any kind of liquid which is actually flowing. Okay. Now, you see that when we talk about the solids, they have a definite shape. For example, the water bottle, a pen, or the laptop, or the mobile phone, anything, all of them have a definite shape. While if I talk about water, which might be just poured on my desk, it does not have any shape, right? It's just going to flow anywhere, but it does not means that it will be never having any kind of shape. It will be occupying the shape of the vessel in which they are being kept. For example, if I pour the water inside the water bottle, then what will happen? It will just turn into the shape of the water bottle. If I just pour the water into the glass, it will turn into the shape of the glass. If I pour it into a bowl, let's say, it will be turned into the shape of the bowl. So it's just shapeless, but it occupies the shape of the vessel. Same is for the gases also. Now there are some important characteristic of the fluid. What are these important characteristic? First of all is that they have very small shear stress. Now if you do not know what is shear stress, first you have to understand about the mechanical property of the solid. Over there it's been expressed a little bit, but let me explain you in a brief that what is the shearing stress. If I have any object, something like this, and let's say I'm applying force on it, then the shear stress is the change, or we could say this is the force per unit area. But what kind of force? This is a tangential force, or you could say, if this is the surface, if this one is the surface and I'm applying force on it, then this force has to be parallel to that of the surface, or we could say this force is tangential to the surface. And now in the case of solid, what happens when you are applying this parallel force? This object will be tilted up a little bit because you are applying force, let's say, from both the direction. But in case of the liquid, they don't have any shape. So if you're going to apply a little shear stress, what will happen? That liquid will start flowing. For example, if you have a drop of water on your table and you just touch it a little bit, or you say that you just slide up a little bit from here, then it will start flowing, right? Okay. Then the gases are highly compressible. What is this point? Okay, one second, let me tell you this thing, that what does this small shearing stress mean? That if you will apply a very little force on this, very little force on this water, then it will start flowing. Very little force can also be responsible for the motion of the fluids. Okay. Then what is gases? Gases are highly compressible because there is a large interatomic distance in between the gases, so they can be compressed and then they can come closer. Okay. Then in the case of liquid also, when you are applying some pressure, then the volume will be changed, but it will not be that much as that of the gases. Gases are very highly compressible, while the liquid also get compressed in the presence of external pressure, but not that much as that of the gases. Now this was a little introduction about this chapter. In the next video we are going to understand about the pressure. Thank you so much for watching.